All right, ladies and gentlemen, today we're going to be learning about dot products and angles. So a quick little do now, find 3u minus v when u is this vector and v is this vector. So that just means 3 times negative 2 comma 3 minus 1, okay, because it's like an invisible 1v, negative 5 comma 4. So do a little bit of distributive property. So this ends up becoming negative 6 comma 9, okay, minus, okay, another distributive property, okay, and this would become, okay, we can add up the opposite of this. So this would be positive 5 minus 4. Okay, remember, just distribute the negative 1, switch out the signs. So now, since we're adding this, negative 6 plus 5, so I'll highlight the ones that get added together. So the purple ones get added together. So those would become negative 1 comma. And then let's say the next color, let's make it the green ones, the y values of this, essentially. So this would become 9 minus 4, 5. And there's your final answer for that. Okay, so this would mean left 1, up 5. Okay, that's how that line would work. All right, let's go ahead and move on. Next, we have the thing called the dot product or inner product. Okay, that's essentially multiplying two vectors. All right, so let me pick a good color. Let's say red. So that would be u times v. Okay, you're multiplying. But notice this is going to end up with a number. Okay, a number is going to be our answer. Okay, or a value. That's a better way to put it. Okay, so you're going to get an amount. So please be very careful to understand that when you multiply, then notice how it's u and v, like u1 v1, and then u2 v2. That's very important. Okay, so let's look at the first example. Given u is that and v is that, find u dot v. Okay, so all that means is, like I did here, the reds are going to multiply. All right, so it's 12 times 3 plus, and then now the blues are going to multiply. Okay, so x's with x's, y's with y's. And so let me keep that blue, and that would be negative 9 times 4. Okay, and so now all we got to do is multiply. So 12 times 3 is 36, plus negative 9 times 4 is negative 36, and this ends up being 0. So that means that u dot v equals 0. And if you ever get the answer 0, this would be orthogonal. Okay, and the definition of that is right here. Okay, the vectors u and v are orthogonal if and only if u and v equals 0. Essentially, it kind of means like they cancel each other out. Okay, so if vectors u and v are perpendicular, then u dot v equals 0. So the word is perpendicular. Okay, that means that they cross each other like that. Okay, or a better way to say it would be if this is one vector, the other one goes like that and crosses it perfectly, forming a 90-degree angle. Okay, so that would be essentially, and that would keep on going, and there's your 90-degree angle. All right, so hopefully that's clear for everybody, and if not, I'll personally help you out during class. So next one, let's try another example. So if u equals negative 3i plus 0j, and v equals negative 2j, all right, so let's rewrite this to make our lives easier. All right, this would be, u would be negative 3 comma 8. And notice how this one's missing an I. There's essentially a 0i right there. V is 0 comma negative 2. So you can use both formats however you want. I prefer to do vector format, but you do you. So now if we're trying to find u dot v, x's times x's, so negative 3 times 0 plus y's times y's. This would be 8 times negative 2 So we end up with 0 plus negative 16. So that means u dot v equals negative 16. Okay. Another name for this would be a scalar product. It says it up here, scalar product. But there you go, guys. That's how you do dot products and angles. Okay. So the UT quest will be due for you guys tomorrow, or sorry, you can get started on that the next day of class. Thank you so much. See you all next time.